Chapter 2.6 is on ratios, rates, and conversions. A ratio is a fraction that relates two values. Again, I think I've said that you can just call a ratio a fraction. A rate is a ratio with the unit of 1 as the denominator. A lot of times, actually isn't always with 1, but that is a unit rate. But again, a rate is just pretty much a ratio in general, and it's just what you would call it. So consider the idea that 25 pieces of candy can be purchased for $5. There are two rates that can be created. One rate is pieces per dollar, so the rate is actually the label, 5 pieces per dollar, because you can put the 25 over the 5, and 25 divided by 5 is 5. The other rate you could do is to do 5 divided by 25, which as you see is 0.2, so 20 cents per piece. So again, the two rates is pieces per dollar or dollars per piece, and that is what your rate is. Again, the ratio itself is when you take the two numbers that are related and you put them into one of the two fractions. So you've got 25 pieces for $5, or you've got $5 for 25 pieces. Again, notice that the word per in your rate is like the division sign of the problem. So when you see pieces per dollar, notice pieces was up top divided by dollars. When it was dollars per piece, notice dollars was on top divided by pieces. And so whenever you have a word problem and it says how many miles per hour did the person travel, it kind of sets up what you need on top, what you need on bottom. Again, whatever is first goes on top. Per means divided by. Whatever is second tends to go on the bottom, or will go on the bottom. Typically in terms of two units that you deal with, dollars will always be at the top of a fraction and a rate. I haven't seen many things where it was pieces per dollar. Usually it is dollars per piece, because that's what your unit price is. And if you have any units of time like minutes, seconds, hours, days, they're usually going to be at the bottom. Think about how people get paid. It's dollars per hour, or people per day, or feet per second. Again, the time unit is typically on the bottom whenever you work with that stuff. Some examples real fast, just some unit price problems. Again, unit price means dollars per something. And so what you're doing here is you have an amount. This is one of your Math Excel questions. If you bought 14 gifts for $85.26, your unit price, first off, remember dollars usually goes on top, so it'll be $85.26 over 14, which gives me a unit price of 6.09. And then the rate would be dollars per gift. Again, the rate is the name. The unit price is 6.09, because that's when you have your dollars on top, your gifts on the bottom. So again, 6.09 is the unit price, because that's how much it costs per unit, per gift. And then again, the rate is based off of this, dollars on top, gifts on the bottom, so it would be dollars per gift. If you're asked to give the proper rate, again, I have a problem on there where it gives some random words here and some random numbers, just to kind of make sure you don't try to do these in your head. It says here 35 wings are traded for 12 hugs. Again, the words really aren't important. What they're asking is the number of wings per hug. But again, this tells me that wings should go on the top, per hug should go on the bottom, which is 12. And so you do 35 divided by 12. And it says to round to the nearest hundredth, which means 2 digits, so 2.92 would be my number there. So 2.92 wings per hug. If you are asked for hugs per wing, you would put 12 on top, because it would be hugs per wing. So you just gotta pay attention to that whenever you do it, so that you're not thrown off by that whenever it pops up. You'll also see questions that ask about which one has the best unit price. This is a real life problem, because you do this whenever you go shopping, or whenever you eventually will go shopping and have to spend money. You don't want to spend more per unit, because then you're wasting money. Although sometimes you don't want to buy bulk, because that's a little expensive. But anyway, if you're talking about unit price, remember again, for unit price, that dollars typically goes on top. So we would do 284 divided by 6.2 to find the unit price, because it's dollars per. So 2.84 divided by 6.2, which in terms of money is 46 cents, so 0.46. And then the other one is $3.09 divided by 8, which is 39 cents per. And so if you wanted to choose the best deal, it's going to be the 8-ounce one. Even though it costs more overall, you're spending less per unit, which means that this is the better buy for you. Alright, so whenever you see that question that says which one's better, choose the one that has a lower unit price because you want to spend less per unit on that, whatever that deal is. We also use rates to convert units. We do this by changing the conversion sentence that we'll see about into fractions. When we will then use cancellation to get the unit that we desire. So the essential question for the day is, why do I need to learn how to convert using the standard method of cancellation? The standard method is used in a lot of physical science classes. So if you're taking chemistry, physics, anything physical science related, it might even pop up a little bit in biology if there's anything going on. But with chemistry and the physical sciences being numbers based, there are a lot of conversions that happen, and it is a trusted method of converting any unit or set of units, because this doesn't just go for one thing like what you're going to see in the chapter. It goes for a whole bunch of different ranges of types of questions that you can use, and so it's good to know because you never know when you might need to convert something. In standard conversion, what we do is we cancel the unwanted unit or units until we end up with the unit that we are looking for. So looking at what a conversion sentence is, the conversion sentence is the two things that make it equal. For example, we know that 1 minute equals 60 seconds. That would be a conversion sentence. It can be converted into two ratios, just like we did in the beginning of the lesson, where one of these goes on top, the other one goes on the bottom, or you just put the 1 minute on the bottom and put 60 seconds on top. These are the two ratios that we create. The reason these ratios are good is because if 1 minute is the same as 60 seconds, that fraction equals 1. Don't write that, but that fraction equals 1, which means that it really doesn't have a value. It's just a name change fraction. Just like here, 60 seconds is the same as 1 minute, which means if you divide something by itself, you get the answer of 1. That is why it's important that you know to create the conversion sentence so that the ratio you create doesn't change the value of the problem, because if you think about it, multiplying something by 1 doesn't change the value of that number at all. We have to make sure we choose carefully when canceling the unit. The way we're going to do that we'll talk about in a little bit. If the actual number we're looking for is on top, we multiply. This is just getting some information before we go to the problems. If the actual number is on the bottom, we divide. I'll talk about what an actual number is in just a second. The rest is learned pretty much through experience. Most of the questions in today's work is going to be on the basic level. We're going to look at some basic problems and use what we see to try one higher level problem, which is also going to be on your homework. Again, just one of them, but just to see if we can kind of use what we know to do that. So it's going to say, given the conversion sentence, convert the units, and the first thing you want to do is take your conversion sentence, which is here, and create two fractions. So we have 1 kilogram over 2.2 pounds. We also have 2.2 pounds over 1 kilogram. These two fractions will help me in some way. Now, we have to also set up our problem, and the way you set up your problem is by starting out with what you want to know. So I start out with question mark, whatever I'm looking for, which in this case is not pounds because I know how many pounds I have. I am looking for kilograms. So I would say question mark kilograms equals whatever I have, which is 95 pounds. Alright, so question mark kilograms equals 95 pounds. What you're going to do then is multiply by one of these two fractions. And the way you choose which fraction that you want to use is by looking at the unit that you don't want. In order to eliminate pounds, I need to move it to the bottom. And so in order to choose the right one, I need the one where pounds is on the bottom. This is not with pounds on the bottom, which means I want 1 kilogram over 2.2 pounds. And what happens is my pound units cancel out, and I have 1 kilogram left, which notice that's what I want. That's why I said you cancel out the unit you don't want until you end up with the unit that you do want. But the thing here is, to multiply by 1 does nothing, to divide by 1 does nothing, so we really don't care about the 1. We're looking at the 2.2. And so in your calculator you type in your 95, but because 2.2 is on the bottom, the actual number is on the bottom, so we're going to divide by 2.2 to get the answer of 43.18 kilograms is in 98 pounds, or 95 pounds, I'm sorry. So again, the first thing is start with the question mark on what you're looking for. write down what you have, set up your fraction, and then make sure that the unit you use to start on these basic ones goes on the bottom. And because this has kilograms on the bottom, we did not want that ratio. We wanted the ratio with 2.2 pounds on the bottom. And because 2.2 was on the bottom, we had to divide. Another one says if 1 inch equals 2.54 centimeters, convert 65 inches into centimeters. Again, first thing I want to do is make my ratios so I don't get confused. 1 inch over 2.54 centimeters is one ratio. The other ratio is 2.54 centimeters over 1 inch. And so again, now that I have these, I can start the problem and I'm not going to be confused when this works out. So notice it says 65 inches to centimeters. Notice I have the number of inches, which means I am looking for centimeters. So question mark centimeters equals 65 inches, and then set up your fraction to see which one we're going to use. Again, we do not want inches, which means if we do not want inches, we want the fraction that puts inches on the bottom. Notice this has centimeters on the bottom, which means I don't want this one. I want the 2.54 centimeters over 1 inch, because what that does for me is it cancels out the inches. Notice again that this is a 1, which means this is not an actual number here, so I don't care about it, and 2.54 is on top. Again, going back to your notes, which says that when the actual number is on top, we multiply. So what we are going to do here is 65 times 2.54 to get the answer of 165.1 centimeters. So again, start with question mark or what you want to see, the number you want here, make sure this unit moves to the bottom. If it's on top, if the actual number is on top, you multiply. If the actual number is on the bottom, you divide. And those are your basic level problems that you have to worry about. But again, there is one on the homework for you ambitious kids, the students that just love to try to figure things out. And this is it. So it has 1 mile equals 5,280 feet. The first thing I'm going to do is make that ratio. So 1 mile equals 5,280 feet, or 5,280 feet equals 1 mile. And they want to convert miles per hour to feet per seconds. Now this is your issue. It's question mark feet per, remember in this case, means divided by. So feet per seconds would be this look, and then you have 35 miles per hour. So what you would do is put 35 miles per hour. So again, how many feet per second equals 35 miles per hour? This is where everything gets interesting, and this is where your standard form helps you out, because a lot of you can't do this in your head, but using the standard form, it works out just fine. Watch carefully as you write also. We know we want to get rid of miles, and miles is on the top, which means we want the fraction that has miles on the bottom, which in this case is not this ratio, it is the one that has 5,280 feet over 1 mile. So in this case we have eliminated our miles, and notice we have feet on top like we want, with feet on top. But if you look at the bottom unit, I want seconds and I have hours, which means that I have to somehow convert my hours into seconds. So what I'm going to do, because I'm not done yet, is put another fraction there. In terms of hours towards seconds, I know that 1 hour equals 60 minutes, right? And so that gives me two ratios. It gives me 1 hour over 60 minutes, or it gives me 60 minutes over 1 hour. Notice here though, as we use our thinking, that hours is on the bottom, which means if I want to eliminate hours, I don't want hours on the bottom, I want it on the top. And so I am going to use 1 hour over 60 minutes, because an hour on the bottom and an hour on the top will cancel. Now we have minutes on the bottom, but we still don't want minutes, we want seconds. So guess what we have to do now? We have to look at the minutes part, which is that 1 minute equals 60 seconds. And because of that, we have two ratios, 1 minute over 60 seconds, or we have 60 seconds over 1 minute. Because minutes is on the bottom, it means that we want minutes to be on the top, which means that this ratio is no good. I want 1 minute over 60 seconds. And notice that your minute parts cancel. Seconds is on the bottom, which is what I want. Feet is on the top, which is what I want. And from there we type it into our calculator. Now this is where the multiply divide thing comes in handy. First off, type in your 35. Second, 5,280 is on the top, so we multiply by 5280. 60 is on the bottom, so we divide by 60. This 60 is also on the bottom, so we divide by 60. And whatever answer you get ends up being your final answer there. So 51.33 feet per second if you're going 35 miles per hour. Alright. Pay attention to this idea that you think that you might have to keep writing these ratios. The reason you write the ratios is so you can see it. But once you practice this enough, you don't really need to write the ratios because you'll understand where you want your miles, and you'll put your 1 mile here, your 5,280 there. Once you understand that you want to go from hours to minutes, you'll understand that you will put the 1 hour on top, 60 minutes on the bottom, the 1 minute on the top, the 60 seconds on the bottom. So don't be intimidated by the size of that problem. Just make sure you practice as hard as you can, and when you get to that question, if you're stuck, let me know and I'll be glad to try to talk you through it. Other than that, like I said, just take your time and make sure you get the most out of the day. Good luck.